Hey everyone, and welcome back. Ready for another deep dive today? We're going to be tackling the Mohs scale.
Ooh, yeah, a classic.
It's one of those things, you hear about it, scratching minerals to figure out how hard they are.
Right, like how tough is this rock?
Exactly, and we've got some really great excerpts from the Mohs scale Wikipedia page to pull from.
Some good stuff in there.
So, let's break it down. The Mohs scale, ranking system, 1 to 10, all about how resistant a mineral is to scratching.
Basically, can this mineral scratch that mineral? That's the gist.
Yeah, simple as that, right?
Well, deceptively simple. You know, this idea has been around for centuries.
Oh yeah.
Like, we're talking ancient Greek philosophers, folks like Theophrastus, Pliny the Elder. They were already onto this whole scratching thing.
Wow, so this isn't just some arbitrary system.
No way. It's rooted in straight up observation, knowledge passed down through what, millennia now?
That's pretty cool. So it's not just about which mineral wins in a scratch-off. It's, like you said, centuries of observation.
Totally. And it's super useful. I mean, if you're out in the field, need to ID a mineral quick, the Mohs scale, it's your friend.
Right. Makes
But
sense.
and there's always a but, right? It's not perfect.
Oh, what the limitations? When does the Mohs scale let you down?
So think of it like this. The Mohs scale, it's ordinal, not linear.
Okay, now explain that like I'm 5, because my brain just kind of went, huh.
All right, picture a race, right? The difference between first and second place is just 1 second.
Okay, a real nail-biter.
Totally. But then the difference between second and third, a whole minute.
Oh, so the order's consistent, but the gaps between them are all over the place.
Exactly. So you see, just because a mineral is a 5 on the Mohs scale doesn't mean it's twice as hard as something with a 2.5.
Ah, so it's not like measuring with a ruler where every centimeter's the same.
Exactly. And this is where it gets really interesting.
Do tell.
Corundum, beautiful mineral, right? Often used in gemstones. It's a 9 on the Mohs scale,
Okay, pretty tough customer.
right? But then you've got diamond, a 10 on the scale. Diamond is 4 times harder than corundum, even though they're just one number apart.
Wow, so the scale gives you a general idea,
Yeah,
but it's not telling the whole story about actual toughness.
you got it. And that's why, in engineering, material science, places where you need to be super precise, they use other scales,
Yeah.
like the Vickers scale, which we'll get into later.
Okay, good to know. So, back to our Mohs friends. We got the 10 minerals, each one representing a level of hardness. Talc, softest, 1. Diamond, hardest, 10.
And what a range, right? I mean, we're talking baby powder soft to diamond, which cuts through almost anything.
It's always interesting to me, though, that even a mineral like talc, as low as it is on the scale, it still has its uses, right?
Absolutely. It's not just about being tough. Every mineral, no matter where it sits on the Mohs scale, it's got its own thing going on, a unique set of properties, and that's what makes it valuable.
I like that. Not just a hierarchy, but like a diverse toolbox.
Exactly. And the more we learn about those individual properties, the more fascinating the world of minerals becomes.
Speaking of fascinating, I read something about how even materials lower on the scale can still leave microscopic marks on harder ones.
Oh,
So it's like even the losers in the scratch test, they still leave their mark.
literally. And that's a really crucial point, one that people often miss. It's not just, a few atoms getting moved around either. We're talking serious implications.
Okay, so like what? Where does this actually matter?
Take electronics manufacturing, for example. Those tiny components, microchips, touchscreens, even the tiniest flaw can mess things up.
So even if I can't see the scratch, it could still be affecting how my phone works? That's kind of scary.
It's true. So understanding those interactions on a microscopic level is how we can design more durable electronics, make sure things last longer.
Huh, so that's where that comes in. Wild.
It's even changing how we develop things like scratch-resistant coatings, even new cleaning materials.
So a simple scratch test leading to all these technological advancements.
It's all connected. And speaking of connections, your sources also talked about how the Mohs scale gets used for more than just minerals.
Right. Like there was that table, wood, glass, even steel had a Mohs hardness.
Exactly. So it's not just about rocks and minerals.
So out of curiosity, where would something like a steel knife fall on the scale compared to, say, a quartz crystal?
Good question. In a scratch-off, quartz would definitely win. Steel, it usually falls somewhere between a 4 and 4.5, whereas quartz is a 7, so quite a bit harder.
So even the sharpest steel knife, not going to make a dent in that quartz.
Nope. And that brings up an important point. We're talking specifically about scratch resistance here, not overall toughness. They're not always the same thing.
Right. It's easy to think of hardness as just one thing, but it's clearly more nuanced than that.
Way more. And that leads us back to some of those limitations of the Mohs scale we talked about. Like what happens when you're dealing with a material that's a mixture of different minerals? You remember those granite countertops from your sources?
Yeah, I remember those.
So why would it be tough to give a single Mohs hardness to a whole granite countertop?
Let me think. Granite's made up of all different minerals, right?
Yeah.
And each mineral has its own hardness level. So it'd be like trying to find the average height of a group of people, but you've got basketball players mixed in with like jockeys.
Perfect analogy. You've got quartz in there, that's a 7 on the scale, but also feldspar, which is a 6, and then you might even have mica, which can be as low as a 2.
Wow, quite a range. So depending on what your countertop's made of, one part could be way more vulnerable to scratches than another.
Exactly. And that's where understanding the limitations of the Mohs scale is super important. It's great for a quick assessment, out in the field, but for some applications, you just need more precision.
Which brings us to the Vickers scale,
Yeah.
right? The one you mentioned earlier, the more quantitative one.
Exactly. The Mohs scale, it's all about a simple scratch test, relative ranking. But the Vickers scale, it gives you a precise numerical measurement of hardness.
So instead of just saying this one's harder, it actually tells you how much harder.
Right. The Vickers test uses a diamond indenter, basically a tiny pyramid made of diamond, presses it into the material with a very specific force, and then we measure the size of the dent it makes.
Sounds a lot more high-tech than just grabbing two rocks and seeing which one scratches the other.
It is. And that level of precision, it's crucial in industries where materials are put to the ringer, extreme conditions where you need really specific properties, aerospace engineering, building tools, even medical implants, all that good stuff.
So the Mohs scale might help me identify a cool rock when I'm hiking, but the Vickers scale is making sure my airplane doesn't fall out of the sky.
You got it. It's all about using the right tool for the job. Both scales are super valuable, they just have different strengths.
It's really amazing how our understanding of something as simple as hardness has come such a long way.
It really is, and it makes you wonder, what other mysteries are hiding out there? What else haven't we figured out yet about the materials around us?
It's like we've gone from those old scratch tests to like using a high-powered microscope.
Exactly. And just like with a microscope, the closer you look, the more you see, the more fascinating it gets.
Totally. So big picture, we've been talking about the Mohs scale, how it came about, that elegant way of figuring out a mineral scratch resistance, but also those limitations, especially when you get into, like you said, high-tech stuff.
Right. And we've also seen how something as seemingly basic as a scratch, how understanding those tiny interactions can actually impact things like electronics manufacturing. Like, who knew?
It's pretty wild when you think about it. Something discovered so long ago still shaping the tech we use every single day.
That's the amazing thing about science, right? You're always building on what came before, refining, discovering new layers of like, whoa, that's how that works.
For sure. So I think we've done a pretty good job unpacking the Mohs scale here, don't you think? Learned a lot in this deep dive.
Definitely. It's amazing how something as simple as like picking up a rock and scratching it can lead to so many insights.
Absolutely. So as we wrap things up here, any final thoughts you want to leave our listeners with? Something to, like, chew on.
Here's a thought. If the hardness of a material can be different even within just one rock, like we talked about with the granite, what does that tell us about all the materials out there in the world? What else haven't we discovered yet? And how could those discoveries change things? Technology, engineering, even art. It makes you think.
Such a good question, and one I hope our listeners will explore further. Thanks for joining us for another deep dive, everyone. We'll be back soon with a brand new topic, ready to dig into even more fascinating knowledge. Until then, happy exploring.